Proving lines parallel. How to tell if two lines are parallel. Now this is important because if you have two lines and even just one of them is off by a hair, the lines will not be parallel. They will, if you continue out the lines forever and ever, they will intersect. So it's really important to have a method of determining how lines are parallel. Well, there are a few ways to do this. Now, the converse of corresponding angles postulate is one of those ways to do this. The converse of some theorems do not work out. However, the converse of this one does work out, and it does work out in a few other places too. Now, if you remember, corresponding angles postulate said that if two lines are parallel and they are intersected by a transversal, then the corresponding angles are congruent. Well, I can flip that around. Let's read this. If the corresponding angles formed by two lines and a transversal are congruent, we know they're congruent, then the lines are parallel. So it's an interesting way to prove that lines are parallel. Here's the problem. There are two lines here that are intersecting. It's like two transversals intersecting two parallel lines. Which lines are parallel if angle 1 is parallel to angle 2, or is not parallel, I'm sorry, is congruent to angle 2? All right, so I'm given that angle 1 is congruent to angle 2, and my job is just going to be to prove that angle A, or that line A is parallel to line B. Angle 1 is congruent to angle 2 is my first statement. That is a given. Angle 1 and angle 2 are corresponding by the definition of corresponding angles. Angle A is parallel to angle B by the converse of corresponding angles postulate. So there you go. It is proven. You could actually use this to prove that L and M are parallel too, because if those two are corresponding angles, then A and B must be parallel and L and M must be parallel. All right, you have some work to do with this. Go ahead and go get it, and we will see you next time.